Hello students, see this problem. This problem, they say the charge density between the plates of a capacitor is given by rho naught e power minus x, and the potential at the boundaries are defined. And now we need to calculate the potential at P between the plates of the capacitor. So basically, you have now the charge density and you need to find the potential. That means you need to solve the Poisson equation. And this is a 1D case, so you can you can write 1D Poisson equation. That will be del 2V upon del x square minus rho upon epsilon naught. And rho value is already given. This is minus rho naught e power minus x upon e naught. And now just you need to integrate this equation and you use the boundary condition, you can find the Vx. So let us integrate this equation. So this give me del V upon del x. So give me minus rho naught e power minus x e naught. If you do, minus will come here and put one constant, says C1. Okay, let me integrate one more time. So if you integrate one more time, this will give you Vx, which will be equal to rho e power minus x e naught. This again become minus. If I integrate one more time, and here you get a C1 x. I'm putting one more constant, C2. So this is my things. Now just you need to solve the equation. So say I want to solve the equation. So Vx, let me calculate the Vx now. So boundary condition says x at x is equal to 0, your Vx is 0. दो बाउंड्री कंडीशन है, x is equal to d also, Vx is 0. So use these two boundary condition and solve Vx. So if I put here x0, so my C2 will become, this become 1, and this become, so C2 will become rho naught E naught. Okay, so now my Vx becomes minus rho upon minus rho naught upon E naught e power minus x, and C2 is your rho upon epsilon naught, and you have a C1x. Okay, so now this become, if I take rho upon epsilon naught common, so this become 1 minus e power minus x plus C1x. Okay, now just to calculate the C1, you apply second boundary condition, x is equal to d, v will be 0, and this become rho upon epsilon naught 1 minus e power d, and then you have a C1. We are writing x is equal to d. So my C1 becomes, if you extend, this will go minus. So this will become rho upon epsilon naught. If you go minus, it will go e power minus d minus 1. Okay, and you divide by this d. This is my C1 value. Now you can write the potential Vx. So potential Vx कितना हो जाएगा? You have already this potential rho upon epsilon naught 1 minus e power minus x. Now you have a C1x. So C1 आपका है rho upon epsilon naught e power minus d minus 1 upon dx. So final expression for potential will become rho upon epsilon naught 1 minus ex plus e power minus d upon dx, and this is the given as a option A, and option A is the correct answer for this question. Hope you like the solution. Thank you very much.